Hi guys, this is Miss Gold. Today's lesson is Module 4, Lesson 4, Markup and Markdown Problems. Your outcomes for today's lesson are students understand the terms original price, selling price, markup, markdown, markup rate, and markdown rate. Students identify the original price as the whole and use their knowledge of percent and proportional relationships to solve multi-step markup and markdown problems. Students understand equations for markup and markdown problems and use them to solve markup and markdown problems. Because most of these problems have to do with real-world situations, we might want to talk about some vocabulary that is going to be used in this lesson that has more to do with the real-world situation than just the specific math. So our first term here is markup, and a markup is the amount of an increase in a price. So when you go to a store, you usually buy an item that has been marked up by the store from the wholesale price that they bought it at. A markdown is the amount of decrease in a price. So when you go to a store and you see things are on sale, it's been marked down a certain percentage. The original price is the starting price. It's sometimes called the cost or wholesale price of the item. The selling price is the original price plus the markup or minus the markdown. The markup rate is the percent increase in the price, and the markdown or discount rate is the percent decrease in the price. Most markup problems can be solved using the following equation. Selling price is equal to 1 plus m times whole. Now what they're saying here is when you go and buy an item, if it's marked up, you're paying for 100% of the item plus the markup percentage rate. So this is then multiplied by the wholesale price of the item. Markdown is similar, except instead of adding, we're going to subtract. So here you take 100% of the item and you would subtract your markdown percentage. So for example, if you go to a store and you find that something is 30% off, if you take 100 and subtract 30, you're left with 70. So what it's saying is you're still responsible for paying for 70% of the item. Let's start by taking a look at example 1. Games Galore Superstore buys the latest video games at a wholesale price of $30. The markup rate at Games Galore Superstore is 40%. You use your allowance to purchase the game at the store. How much will you pay, not including tax? Write and solve an equation to find the price of the game at Games Galore Superstore. So if we take our formula from the previous page, we know that our sale price could be considered our unknown, which is X, is equal to 1, and it's a markup, so it would be plus 40%, which as a decimal is 0.40, multiplied by the whole, meaning the wholesale price. So the original price that they paid was $30. So we could simplify this equation, first by combining like terms inside of our parentheses. 1 plus 0.4 is 1.4. And when I multiply that by 30, we get a final price of $42. So the final markup price of the game is going to be $42. What was the total markup of the video game? So when I look at our final price of $42 and subtract out our original wholesale price of $30, we're left with $12. Tells us how much the price was marked up. The markup was $12. You and a friend are discussing markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? Now, if you're asking for just the markup, which we just identified in the last section was $12, I would agree with him. What they're doing here is they're doing percent times whole equals part, and that tells us what the markup is. So here, 40% would be 0.4 times the wholesale price of 30 would give us 12, which does tell us our markup rate. Example 2 says a $300 mountain bike is discounted by 30% and then discounted an additional 10% for shoppers who arrive before 5 a.m. Find the sale price of the bicycle. So in this case, I am going to start with our equation again. Now in this case, it's discounted by 30%, so what they're saying is it's a markdown. So the first thing I'm going to have here is 100%, which is 1, minus 30%, which is 0.3, multiplied by the original price of the mountain bike, which was $300. Now this is just going to tell me what the discounted rate of the bike is. After that, we're going to have to find the additional 10% for those who arrive before 5 a.m. So to simplify here, we have 100 minus 30% leaves us with 70%. And when I multiply these two, we get a final result of 210. So the new discounted price is $210. However, there's an added piece to this. If you arrive before 5 a.m., you're going to get an additional 10% off. So again, that's another markdown. But you have to understand that it is a markdown off of the sale price, not the original price. So here, we're going to call this one Y to show the sale price before 5 a.m. 100% minus 10%, which is 0.1, multiplied by the sale price of 210. So I'd simplify here, 100% minus 10% leaves us with 90%, which is 0.9. Multiply by 210. And that gives me a final sale price of $189. So we have two different sale prices here. If you arrive before 5 a.m., you're going to get a sale price of $189. And if you arrive after 5 a.m., you're going to get a sale price of $210. Part B says, in all, by how much has the bicycle been discounted in dollars? So we're looking at the lowest discount, and that was $189, and it was originally $300, so I'm going to subtract those two. And we find that it was discounted $111. Because 300 minus 189 is 111. Part C says, after both discounts were taken, what was the total percent discount? So if I'm looking for a percent discount, what I interpret this to mean is percent change, which we've learned the percent change formula before, 2 minus from over from. So let's start with that. Percent change is equal to 2 minus from over from. So the 2 in this case is what the discounted price went to, which was $189 from 300. So when we subtract that, we get 111, which we already knew from our previous question. And divide that, we get 0.37, which is equivalent to a 37% discount. Example 3, working backwards. A car that normally sells for $20,000 is on sale for $16,000. The sales tax is 7.5%. What percent of the original price of the car is the final price? Now, in order to know the final price of the car, I would need to calculate what the sales tax is, and a sales tax is always going to be a markup. We have to add on the sales tax to the sale price of the car. So let's start with our formula. X equals, we have to pay for 100% of the car, so that's 1 as a decimal, plus 7.5% as a decimal is 0.075. And this is multiplied by the sale price of the car, which is $16,000. When I simplify this, we get 1.075 multiplied by 16,000. And that gives us a final price of $17,200. So now I can figure out what percent of the original price of the car is the final price. So when I'm talking about a percentage, you know, a percent is the part out of the whole. So I can just plug in these values. The part would be our final sale price out of the whole price, which was $20,000. When I divide these two, I get 0.86, which is equal to 86% of the original price. For part B, I'm asked to find the discount rate. Now, what they're referring to is the sale price on the car. So we're only really focusing on $20,000 and $16,000. So again, if we're looking for the discount rate, we're looking for percent change, which we said is 2 minus from over from. So in this case, the car went to a price of $16,000 from $20,000. So when I subtract these two, I get negative 4,000 over 20,000. And this gives me negative 0.20, which is equal to 20% discount. Finally, Part C says, by law, sales tax has to be applied to the discount price. Would it be better for the consumer if the 7.5% sales tax were calculated before the 20% discount was applied? Why or why not? So let's go through and actually see what we would get if we calculate the sales tax before the discount. So I am calculating when we have 100% of the cost of the car plus the sales tax, which was 0.075 as a decimal, multiplied by the original price, it's $20,000. When I do that, I get a value of $21,500. After that, what we're going to do is to apply the discount rate. So in this case, we are actually doing a discount, which would be subtraction. So you take 100% of the item and subtract what we found, which was a 20% discount, is 0.20. And that's multiplied by the price of the car, which is $21,500. So when I multiply these two, I actually get a result of $17,200, which if you compare to what we found in Part A, they're equivalent. So really that tells us it doesn't make a difference which is calculated first.